All right, so we have looked at the slope. We've looked at slope on a table. We've looked at slope on a graph. We're now going to go ahead and look at slope formula, okay? The slope formula, basically what it does is it uses two coordinates. It uses two coordinates, and then we use the formula to figure out the slope, okay? And the way we do that is the following. So slope being m is equal to y2 minus y1 over x2 minus x1, okay? What you need to understand is this, okay? x1 is the x-coordinate of the first point. x2 is the x-coordinate of the second point. y1 is the y-coordinate of the first point, and y2 is the y-coordinate for the second point. Okay, so we need to keep that in mind as we're solving these, okay? All right, reminder, whenever we see coordinate points are always given x and then y, okay? So they're always listed like that. So we have the x coordinate first and the y coordinate. So when I go over here to my graph, okay, I know that this is my x axis, this is my y, okay? So, and I have 2 points already on here that you can see identified, okay? So the first thing I'm going to do is identify this point right here. So I look at the x-coordinates, so I start at the origin, and I go and see how far I go over to get on the x. In this case, it would be 2, so it's going to be 2. And then I see how far I went up, and I go up 1, so the y-coordinate is 1. So the x-coordinate on this, x-y coordinate on this one would be 2, 1, okay? I go up to this point now, I'm going to go the xy coordinate of this one. So how far over did I have to go to get there? That was 3. How far up did I have to go to get to this coordinate point? I had to go over to 5. Or I had to go up to 5. So the coordinate point is 3, 5. So again, this is my x coordinate, this is my y coordinate. From here, now I just label them 1s and 2s, and I can do whatever I feel. I can either label both of these 1s, or I can label them both 2s, but they must be labeled with the same number, okay? For this problem right here, I'm going to go ahead and label these 2s, and then these are going to be 1s, okay? So my x, or my y2 is 5, so I'm going to write this over here. y2 is 5. x2 is 3. y1 is 1, because it's the y coordinate there. And my x1 is 2. Okay? So I'm going to use that, and I'm going to substitute that in for this slope formula, so that I know that slope m is equal to y2 minus y1 over x2 minus x1. So what I'm going to do is I'm going to substitute numbers in for y2, y1, x2, and x1. So I'm going to, first thing is I'm going to start with y2. y2 was 5, so I'm going to put 5 minus the y1 coordinate. So I go down here, y1 was 1, so I'm going to do 1. Okay. Next, on the bottom, I'm going to do x2 coordinate. x2 coordinate was a 3, so I'm going to put a 3 down below that 5. Notice how that those are the 2 coordinates for the second point. And then the x1 was 1, or sorry, it was 2. So I'm going to put a 2 in there. So my slope is going to be 5 minus 1 over 3 minus 2. And so if I do my math there, 5 minus 1 is 4. 3 minus 2 is 1. And so as a result, I get a slope of 4 over 1. All right. Let's go ahead and go down to another point. All right, this graph, or this slope of a line is noticed on all 4 quadrants. Again, just a quick review: quadrant 1, quadrant 2, quadrant 3, quadrant 4. You'll notice a slight difference between this line and the other line that we looked at. This one appears to be going down left to right, whereas this one was going up left to right. Okay, so kind of notice the difference when you get an answer here in the end. Okay, so I notice I've labeled 2 coordinate points, this one right here and this one right here. I'm going to go ahead and identify those 2 coordinate points. So this is x, which is 1, and then the y is 1. So that coordinate point is 1, 1. I'm going to go label this coordinate point. So to get over underneath it, I have to have -2. And then it went all the way up to 3. Okay. So on this one, I've got the coordinate points labeled. Now I'm going to label the x1s and y1 and the x2 and y2. I'm going to call, we'll just call this one x1 and y1. And we'll call this one x2 and y2 on this one. Okay. Again, knowing I could have called this one x2 and y2 and this one x1 and y1. All right. So I'm going to use the slope formula again, just in case anybody's forgotten. Here it is. M is equal to y2 minus y1 over x2 minus x1. So now I'm going to substitute numbers in. So I look down here at the y2. What number was y2? It was a 1, so I'm going to put a 1 in there. Subtract y1. So I go over here. There's y1. What number was y1? That was a 3. All right, sorry. So now I'm going to do x2 and x1. So I go ahead and look at x2. x2 was 1 right here, so I'm going to put a 1. y1 or x1 right here, which was a -2, so I'm going to do minus a -2. Keep it in mind, when I subtract a -2, that's like adding a positive, so I'm going to do a plus plus. Okay. So I'm going to go ahead and solve this. 1 minus 3 is -2. 1 plus 2 gives you 3. And as a result, you get a slope of -2 over 3. All right. You should never have a negative number down below. Okay. So keep that in mind. You should never have an x coordinate or x value that is negative. So if you do have just an x down here that's negative and a y that's positive, then just put the negative out in front. Okay, if they're both negative, that would mean, so for example, if you get -2 over -3, -2 over -3 is really just 2 over 3. Okay, so this one you notice was a negative slope. So hopefully you start to identify which lines are negative and which lines are positive. So when we look at this third example, hopefully you can take a look and you can immediately kind of figure out, is this a positive slope or a negative slope? So it's going left to right, and as it's going left to right, it's going up. So as a result, I know that this answer has to be a positive slope. So I'm going to go ahead and pick my 2 coordinates again, which are these right here, and this one right here. I'm going to go ahead and label them. This would be -2, 1. It's -2 and 1. Over here, this would be 3, 2. And again, this is the x coordinate, this is the y coordinate. Okay. So now I'm going to go ahead and use my slope again, what I have, y2 minus y1 over x2 minus x1. And again, that's what my slope is equal to. So I'm going to label them x1 and y1, x2 and y2. I'm going to label this one x1 and this one y1. This one's going to be x2 and y2. Okay, so now I'm going to go ahead and substitute those in there. So y2 has a value of 1. Subtract the value of y1. y1 is right here. It was 2. Okay. Over x2. x2 was -2 minus x1, which was 3. Okay, so again, I got that right there because that was the x1. So now I'm going to go ahead and solve. 1 minus 2 is -1. -2 minus 3, that's like adding a negative. So -2 plus -3 is -5. So notice here, this is what happens. I get -1 over -5. When they're both negative like that, I turn it to a positive. So it's going to be 1 over 5. Okay? So I only get to do that when both the x and the y are both negative. Can I change it into a positive? Another way to think about it, a negative divided by a negative is a positive.